Alright, in the previous lesson we explored the pandas time delta object, which represents a duration of time. And in this lesson I'll show you how that concept might apply to a real-life dataset. To do that, I'm going to import a new CSV file called ecommerce.csv. So let's take a look at it. I'll begin by calling my read CSV method on my pandas library, just like always. Let's open our set of parentheses here and provide the file name as our very first argument. So I'm going to type in ecom, and then don't be afraid to use that tab key to autocomplete the file name. Let's take a look at what it looks like upon the initial import. So you can see it's a pretty simple data set. This is a representational basically of our shipping structure as a company. All of these dates of course are fictional. We have an ID column as well as the order date that we shipped out a product and the date that it was delivered to our end customer. So there's a couple of things I want to do here. The first is setting that ID column as the index of our data frame. So to do that, I'll use our familiar index call parameter, index underscore call for column, provide that equal, and in double quotes write the column name we want to set as the index, which is ID. And there we have it on the left there. And the second thing I want to do, if you actually take a look here, these are not currently being brought in or parsed as datetime or timestamp objects. They're still resembling strings. The reason is that pandas is going to default to strings no matter what if it can't figure out what it is that you're importing. So we have to explicitly tell it that we want to interpret these as datetimes. The reason you can tell they're not is because a datetime or a timestamp object will have that familiar aesthetic format where it has the year written, then the dash, then the month, then another dash, and then finally the day. Here we have those familiar slashes, and the years are written without the two leading digits, so we know that these are being interpreted as strings. So let's provide that additional parse dates parameter here, parse underscore dates, and we can provide it a list of the columns that we want it to parse as date times or timestamps instead of strings. So I'm going to write both of our columns right here, order date with underscore, comma, delivery date. Let's take a look at what this new iteration of our data frame looks like. And there you can see now that familiar syntax has appeared. We have our year up front followed by the month and the day, and they're all separated by dashes. So our import process worked successfully and was successful in converting. Now I can store this imported CSV in a variable because I'm happy with the results, and let's just call it shipping. And as always, I'm just going to put the preview out there by calling the head method and providing it an argument of 3, just so we have a track record of our first 3 rows. So here we have 2 columns, each with timestamp objects. Let's say we want to find out the duration between them. Let's say we want to find out how long it took to get it. We don't want to manually count the days between these 2 dates. We'd rather just subtract them. And just like in the last lesson where we did one example where we subtracted 2 timestamps from another. I remember we did time A and time B. In this example, we can provide that entire operation, but do it across 2 different series here. So it's going to be pretty simple. We're going to begin with the column that we want to subtract from, which, as I mentioned, is easier to make it the later date, which in this case is going to be the date it was delivered. So let's do shipping, and then select in square brackets my delivery date column. There I have that series. And from it, I want to subtract the values from my order date column. So my syntax is going to be the same. On the right side here, I have my other series, which is order date. And of course, it's going to match up these subtraction operations by their commonly shared index, which is going to be the same here. So now let's take a look at what happens when I do this. Well, I'm going to get a series that consists predictably of pandas time deltas. We can see here it says 257 days. It's not a specific date or moment in time, rather it's a duration. And if I scroll down all the way to the bottom, we can see that the data type is no longer listed as date time as it would be for our 2 original series, but rather it's listed as time delta. So now that I'm satisfied with this result, I can assign this as a brand new column in my existing data frame. To do that, I can just add an equal sign and create a brand new column. I'll still use my shipping data frame and generate that brand new column by providing it in square brackets, in double quotes. So let's create something called delivery time. And now if I execute this and take a look at my first 3 rows of shipping, we've created a brand new column that specifies how long it took for that package to get delivered. You can see this one took 6 years, so it took a considerable amount of days to get there. Now, we can also create brand new series by combining timestamp and time delta columns. So for example, if I wanted to find out what the day would be in the future if the delivery time took, let's say, twice as long, we can do something like add the time deltas in our delivery time column to our delivery date column. So even though they're two different data types, Pandas is able to combine them together, much like it does when we added a regular time delta to a regular timestamp. So if I begin by extracting my delivery date column, there is my series of the dates it was delivered, pulled from here, and I want to add the values from my delivery time column. What it's going to do is take the start date from each row and then combine it with the delivery time listed. So it's going to add 257 days to this delivery date, and it's going to give me a brand new series. Now, of course, whenever we combine a duration and a specific moment in time, it's going to give me a new moment in time. So the result will be date times. It's not going to be time deltas. But this date, 10/20, October 20th, 1999, represents the date that's 257 days after the February 5th, 1999. Predictably, if we use minus, we're basically going to be subtracting this amount of days from here. If we do that, we're predictably going to get the order date. And you can see that they all match in these original results. So now I can add this plus. And now if I'm satisfied, we can say something like shipping, create a column called twice as long. I don't know why you would calculate this. It's just demonstrating what we can do with these time delta and timestamp combinations. And now we have our brand new data frame. We have those columns. You can see that the timestamp and time delta integration works perfectly. We have 3 columns now of date times and 1 column of time deltas. And I can demonstrate this by using that dtypes attribute. And you can see here that we're going to have predictably 3 columns of date times, 1 column of time delta, and now we can do all kinds of different operations. For example, if I wanted to filter those that took more than a year to deliver, I can do something like shipping delivery time. Let's pull out that column, and let's do something like greater than 365 days. And it's going to give me a Boolean series for true wherever the delivery time is greater than 365 days. And again, the really great flexibility here is that it's going to be comparing time delta or duration values with this string that I passed in. Pandas is obviously able to figure out what I mean here. And now if I want to assign this to a variable called mask, and then filter for those values, I can see what are some of our absolute worst orders where we took the absolute longest amount of time, greater than a year. I can even do something like greater than 2,000 days. Let's take a look. And there you can see that. Let's do greater than 3,000. What a terrible shipping service we run here. Here you can see that. So it's very simply easy to filter for that kind of stuff. And of course, you can do things like less than or equal to find shipments that took an exact number of days. For example, if I want all the shipments that took exactly 3,423 days, I can put this in here, change this to a double equals for the equality comparison, and there you can see that was the only order in our data set that took that long. We can also do things on our time delta columns like max and min functions. So for example, if I do shipping delivery time, there's my series of time deltas. I can do things like max. You can see that that's the longest shipment. We can also see the shortest delivery time by calling the min method. You can see the shortest one took 8 days. We run a pretty terrible shipping service here. But you can use that to find things like shipments that took the shortest, the longest. You can filter. So whenever you're working with things like dates, using time deltas can be a really efficient way and a really great way to filter to find the results you want, because those moments in time aren't always the easiest way to filter specifically by days, while the delivery time or the time deltas kind of gives you a more equal playing field. Now, even if we have date times across multiple years, we can see which ones took the longest, which ones took the shortest, and so on. So that's how you might use time deltas in a real-life data set to see time calculations.